Connecting cities with a minimum cost. Start stopwatch. So there are n cities labeled from 1 to n. You're given the integer n and an array connections. And then connections I is equal to xi, yi, cost I. Nice. Okay, so xi, yi, they're just different endpoints, and cost I is how much they cost to get from x to y, basically, right? And then, yeah, that's what they say. Bidirectional. Oh, it's also bidirectional. Okay. Now we need to return the minimum cost to connect all the n cities such that there is at least one path between each pair of cities. Okay. All right. The cost is the sum of the connections costs used. Okay, for example, we got 1, 2, 3 here. Um, okay, 1, 3, 6, 2, 3, 1. So they already gave us they gave us the connections already. Oh, I see. And then the output would be 6 because oh, I see. I see. I see. I see. And the second example is -1 should be, right? Because you cannot connect all of them, right? Okay, this is the idea. Cool. So each city, the connection array and whatever, we can try to use stack. Um, uh, holy shit. Mm. Wait, this. What should I do with this one? I'm trying to think about some solutions here. I can do. So, huh. I feel like first of all, if I have three nodes, then to connect them all together, like each one has to connect together, then there has to be at least two edges, is it? Um yeah, that would work, yeah. Or um damn, we should do a linked list, bro. I think if we do a brute force, if we start from brute force, right? We can do damn. Is this a binary tree? Could this be a tree? Holy shit. Um, man. N, wait, what is N again? N is how many nodes, right? N cities, cities. Okay. Another day of consistency. Yes, yes, sir, yes, sir. I'm so bad. I don't know how to do this one, bro. What's up, man? What's up? Wait, they already gave us N, so we already know how many cities are there. So if N is smaller than LAN connections, um, -2, right? So if you have 3 cities, the minimum way to do it is 1, 2. It's like that. Return the minimum cost to connect all the. There's at least one path between each pair of. There's a path, but there can also. Yo, what's up, man? What's up, Rishi? So you have 4 of them. Then there's 1, 2, 3. No, there's at least. Yeah. 3 path, 3 connections at least to connect them. Yeah, but they can also still not have any. So if you have like 4 connections, so in my small brain, I would say, hey, if the connections are, there are not many connections. There's only like, say, wait. Oh yeah. If the length of connections smaller than nodes, cities, and -2, -1 actually. So if you have 4, you need to have at least 3 connections going on so that it works. Then we return -1. Okay, let's leave it at that. So now we're assuming that there must be connections now. Okay. Now what you need to do is find them the smallest path of them. Hmm. Can I just do like? Can I just do? No, I cannot. I can find all of the path, and then maybe but that's not optimal. That's like brute force. Well, then let's do brute force then. Fuck it. I don't know how to do. I don't know how. I don't know if there's like a good way to do this, bro. I don't know. So my idea of brute force very simple. Find all the cities, all the path, and then find the one that has the find this minimum cost from it, right? Um, so fuck man. For connection in EC is total cost. Uh, hmm. Um, if path uh okay, shit. And then that's what happens when the when path is empty, you know, add the first one, the first two nozzles, two cities, my bad. And then if the path exists, that means we already added the first two cities. Now we're getting going to the next one, okay? Path uh 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 um 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 oh, hold on. What is it? Path dot append the um wait, it's dynamic programming, bro. It's dynamic DP. Okay, hold on. Mean TC is this, and then TC the cost equal to the mean, either this or 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 what? Holy shit, it is. It is, motherfucker. Um, so yeah. Wait, how do you do a 2D array again? I forgot. Python, how to initialize 2D DP, I don't know. The fuck? Oh, like 0, 0? Okay. Um, um, How many zeros do we want though? Bruh, it's n0, bro. N0. And then this with times n again. Right? So the idea is that we want to find out like the cost of each from each city to each city, you know. And what's gonna happen is, holy shit, we're gonna populate them one by one, right? So one by one, one by one. So let's construct DP table right here. Let's say we have one. Shit. Let's say we have like that's 3 cities, right? Like what we have above, and 2, and then 3, and here I have 2 and 3. Shit, 3. Now for the first one, of course, this is 0, and this is also 0, and this is also 0. Fucker. And then from 1 to 2, let's say this example, we got 5, and then from wait, but how do we track? How do we trace? You know, how do we trace the minimum cost? We should trace them in the variable, or so right now it's 1, 2, it's 2, it's 5, but then we also have connection with 1, 3, which is 6. And when we go to the second row, we're like, what is 2 to 1? Right? What is 2 to 1? Can we find a path to do that? We surely could by doing J, and then we can say, hey, that's just 5, no? Either it's 5 or we can find something smaller, which is fucking crazy. I don't know. Oh, and here 2 to 3. Haha. Guess what? Guess what? Um, we find 2 to 3. 2 to 3 is 1. Now the $1,000,000 question is, what's 3 to 1? So we know it's 6, right? But it can judge. It can be like, um, in reality, 3 also connects to 2, and 2 connects to 1, so we can do add them up together, you know? Shit, this is so hard. Um, it is still 6. That's for sure. Hold on, let me go to the bathroom real quick. I need to poop. Brad, need to poop. Shit, bro. That's a medium question, by the way. Bro. Okay, fine. All right. How long should I do it? It's usually like 20 minutes, but I want to give up now. So, yeah. The idea is two to three. 3 to 2. And you can only find you only find one, right? But how does that work? You know, how does the recursion work? I don't get it. Trying to see, bro. So at the end of the day, we can just add that all of the thing here. You know, man, I don't know. Fuck, man. Oh, should I sort the thing first? Not necessarily. We don't have to, right? Um, Once we get this, we can do like path. Dude, for n, for I in n, for j in n, we do path I j equal to wait, oh my god. You gotta find connections first. Oh shit. Oh shit. Oh shit. Wait. You don't need to do this. For C in connections, we can just do A B equal to dp 0 dp. Whatever. This don't work. This don't. So dpab, okay. Uh, will be equal to C2 or the do you know Kurzweil's algorithm? Fuck man, I forgot. I think I learned about it 2 years ago. What is it? That's a good question because I don't know. Oh, holy shit. MST. Do I need to relearn the algorithm? Wait, you know what? That's exactly what it is. What the hell? Alright, man, I give up now. I give up now. This is crazy. Damn, I'm still using DP and there's actually a algorithm to do this. Oh my god, sort them. Wait, I actually recite this before for my class. That you have to recite them and then memorize them. Holy shit. Right. That's a Sudoku. Oh my god. Yeah. Yeah, yeah, right. This is exactly what it is. Holy crap. But I want to see if this can be I want to see if I want to see if the DP works too. I don't want to waste more time now. I know it's wrong. But let me see if this works too. The mouse AI can is this is not optimal solutions. Yeah, it's not optimal. The graph connectivity is global. Oh, it's not local decision. Damn, bro. There's also Prim's algorithm. Yeah, man, I need to look at all the graph algorithms. Wait, what is Prim's algorithm again? I remember I have it in the Leetcode. I have it in Leetcode template. Wait, I remember I have it though. I have it somewhere. Anyway, I gotta go later. Okay, fuck it, man. This is bad. So the idea is, oh, this is correct though, right? This is right. Yeah, I got one right. And then you have to sort them. Okay, you have to sort them. That's the idea of Kruskal's algorithm. You sort them and you find the what? Find the minimum one and add them all together. What the hell is X? Oh, based on the second one. Okay, yeah. Yeah, right, you're right. Oh my gosh. Wait, by default, you sort them based on uh ascending order. Okay. Damn. And now the parent is equal to list. What is union find? Damn. Hold on. What does parent do though? What is the least? Oh, okay. Dude, that's smart as fuck. What the fuck? That's so smart. Now we can find them, right? We find X. And then we need to also have a union function. So find, we're finding parents basically. If parent x, which means this city's parent is not itself, then that means find parent x. The fuck? Wait. Wait, I don't get this recursion. Find parent x. Isn't it the same thing though? What the hell? Oh. Oh fuck. But when are they changing it though? Oh. Oh, I see. It happens in the union. It happens in the union. Okay. That's interesting. Wow. Wow, that's interesting. And then union it, to union it, it just is connection. Parent x, parent y is equal to find x, find y. So they're union everyone first. They're populating the parent first, all of the thing. Okay. Now TC equal to 0, edges used. Then for A, B cost in connections, if union AB, that means we'll find a valid edge, whatever. And then TC just cost. Wait, what? Does that work? I thought that's just my intuitive. Or otherwise return -1. Fuck. God damn it. Wait, my salute. Wait, what? Fine and union. That's what Cruise Scout is. 99%. Dude, I got lucky, bro. What the fuck? Okay, let me reset this. Oh my gosh, this is so long though. But the idea is to sort them based on costs. Yeah, yeah. It's tricky, yeah. But if I know, if I memorize the algorithm, this problem should be easy. This problem should be easy. The length of the connection should be smaller. Yeah, that should be the maximum because it's bidirectional. If it's bidirectional, you need to have at least n-1. Yeah, you sort the connection first, and then you do the parent. You initialize the parent list. 0 to n, 0 to n+1, because it's not inclusive at the end. And then you define the find function, define the union function. So this is the main part of this algorithm. For find, if parent x is not x, you try to parent x equal to find. You do the recursion until it finds the actual parent, the source parent. Okay. And for union, you're just trying to define px equal to p. Okay. Do that first. Okay. It's gonna be hard to memorize this one. And then at the end of the day, you do A/B cost in connections. You iterate through all of the connections you have. And then if union AB, this part we're trying to put them in a parent list. TC equal cost. Yeah. Wait, but how do you know that's the minimum? How do you make sure it's minimum though? Oh, because you're doing edges used. Is that right? Or oh, because you already sort them. You sorted them. You sorted them based on cost. So you're always adding the not so expensive costs. And you only add them until that the address uses n-1. I see. I see now. I see. All right. Fuck. Let's do it. Let's redo. Shit. What I do? First, let's check if it's even possible, right? If len connections is smaller than n minus 1, return -1. Right, let's check if it's even possible to have connections with every pair. Now what? We need to populate parent list, right? Parent equal to list. Range n plus 1. Right? Now we need to have find union, the classic combo. Find x. And we have def union xy. Dude, in the interview, if you just know this question, you're like, hey, I know. But you don't want to, you want to be like, I did this already. No. You gotta do like, well, I think we should check. Just get into it, get into it. Find x, parent x equal to, if parent x is not equal to x, then what I do? Equal to find x. Otherwise, you return parent x. Wait, find parent x. And then you return parent x, right? Is it? Okay, first off, px, py equal to find x, find y. Okay, now what? Now what? Union if they're not themselves. If they're not themselves. If px is not equal to py, then we need to union them. We need to union them. We go back to parent px. That should be py. Wait. I didn't sort them, right? Wait, how do I sort them? Though, I forgot. Sort, like this? Just do that. Sort, parent. Wait a minute. Sort connections, right? Key equal to lambda x2. Something like that, right? I don't remember. Anyway, let's just keep going. Anyway, we're assuming this is right. Okay, we sorted them. Now we have total cost. No, we're just doing union right now. And then here we return. Oh yeah, we have a union. If now we don't. Okay, and then we now start doing the real shit. TC equals 0. What else do I need to initialize? I forgot. Fuck it, don't care. If for A, B, for X, Y, cost in connections. Right? Is it connections? Okay. If union X, Y, we just say, aha, we find them. Now what? Now we just TC plus equal to cost. And if, oh yeah, and then edges used equal to 0. Edges used plus equal to 1. And if edges used is equal to, I don't know, m-1. In that case, that means we have exhausted all the options, and then we can just return TC. Otherwise, return -1. Is that right? Damn. What's up? Hi, Ayush. How's it going? Yeah, I forgot how to use sort. I forgot how to use sort. Let me just do this real quick. Doesn't count. This is not cheating. I'm just trying to see the context. Oh, you dot sort then. Okay. Connections dot sort. Oh my god, I'm so washed. Does that work? Oh yeah, let's go. Fuck, man, this is so hard. Let me see if that's right. We don't need to have parentheses, so yeah, yep, that's an issue. What else did I do wrong? I think that's fine now. Dude, I need to review this question from time to time, bro. It's okay. I'm having a one day I will master this type of questions. One day. You know, just keep going, keep grinding, chat. Every day. Yo, I don't care. Even if I get a job, I think I will still do Leetcode just to stay sharp, you know, just that like to be professional and shit. Well, anyway, this is for today. Keep grinding, everyone. Don't give up. See you tomorrow.